piece about daily beauty for microplastic.
And our team name is microplastic.
I'm Lydia Liu. I'm an 8th grade student. I come from China. I'm really passionate about making the world better and finding a healthy lifestyle for the people, especially reduce the plastic around us.
I'm Xiaotian from 8th grade and come from China. I'm interested about microplastic and its harm since 5th grade, but I'm too small and inexperienced at that age, making me not starting this planning. In 8th grade, having the opportunity of making experiments about this topic, I began this journey.
The SDG goals that related to our product is 6. Clean water and sanitization, and 3. Good health and well-being. Our goal is to protect people's health and living style by reducing the consumption of microplastic. Our product will be focused on mini, micro, and will be portable and test at home easily.
These are the ways of how microplastic impacted people. There are microplastic paint, plastic platelets, synthetic textiles, tires, and personal care products. The biggest problem we are focusing on is microplastics. According to our research, adults could consume between 39,000 to 52,000 microplastic particles a year on average, which estimates to eating 200 to 260 plastic straws. Additionally, plastic will also lead to breast cancer. Some chemical used in the production of plastic, such as carcinogens, are to increase the risk of developing certain cancers, based on our research, such as liver cancer, brain cancer, and leukemia. Second, children's body developments. Chemicals from plastic can alter brain development, which will cause behavior problems and increase risk of many diseases.
And the most important thing is people are eating plastic without noticing, and this leads to a question: how can we solve it? Our solution is to use a microplastic detection device to test how many microplastic is in the water. It can be used when the customer can't determine if the water can drink or not. It protects them from drinking water that contains too many microplastic. Additionally, protect their health. Let Rachel introduce the specific information of our product.
First, we will have a filter sheet on the bottom and it is 0.45 micrometer cellulose acetate as the base material. You can look at the picture. By immersing it into 10 micrometer per millimeter nail red Actom solution for 30 minutes, it can allow nail red molecules to bind to the filter sheet to let the sheets become dry for 1 day. This will be the main material for testing microplastic. This is called a nail red method, as you can see on the right side picture. It is mainly a fluorescent dye commonly used in biological and analytical chemistry. It can help on observing microplastics clearly. The second model is transparent styrene. The green color model is the outer part, hollow inside. The blue model is in the part solid inside. The conductor will place blue model inside the gray ones and push water out. This styrene can contain 200 mm water, which is efficient on testing microplastics. The second model is transparent styrene. The green color model is the outer part, hollow inside. The blue model is in the part solid inside. The conductor will place blue model inside the gray ones and push water out. This styrene can contain 200 mm water, which is efficient on testing microplastics.
This is the way to let microplastic review. It is a cube-shaped light type box on top lid that can open and close, which you can place one filter sheet that was pushed with water by steering into this lid. And the door can reduce the intensity of light. A long rectangular observation port on the side, equipped with the orange transparent color panel. Place it on one of your eye. You may have a question: how can we store all the filter sheet? And here's the answer. We build a filter sheet storage case. It is a sealed, moisture-proof storage container with a partial slots to separate pre-stained CA filter sheet. There will be a designated to maintain the dryness.
Nail red stained microplastics in water samples can be efficiently seen on 0.45 micrometer cellulose acetate filter sheets, and their fluorescent signals can be visualized and quantified in the observation box, making sure the user can detect microplastic at home in a short time. Furthermore, our standard for how many microplastic in the water is based on research. If there are 2 or more microplastic being observed using 200 mm water, then it's harming people's body.
So for our solution, we can let people notice that how many microplastic is in the water, which solve the root cause. And then for the impact, people will have less chance of getting cancer caused by eating too much plastic. Also can prevent impacting the development of the next generation. This can impact people's quality of life and benefit their health.
Thank you everyone.
Having a better future for starting caring yourself.
Bye bye.
Bye bye.